Hi, my name is Bob Greenyer, and I'm a volunteer with the Martin Fleischmann Memorial Project. So welcome this 27th of April 2025 to O-Day, Unipolar. How is everyone this wonderful early spring summer? I think it's coming into summer. It felt so lovely today here in Central Europe. How are we all? We have Artifact in the house. Hello there in Germany. Gordon Doherty. Hello there in UK. Beninator. Nathan Ford. Corky Goss. Boom. Yes, you're a little bit premature there, but we might have a boom. Hi, Damien Knowles. Hello, Matthew Reynolds and Joseph Connor. Athena Mac. Casey the Cat. Power and Pep. Venom K. Mika Avila. We have a lovely quorum. Thank you for being patient. Hello, Phil Dubois. How are you? Hello, EBB. Up there in Canada. Crypto Alchemist. Another Canadian, are we? Yes, we have a full complement here. So thank you very much. Hi, Pamela. Hi, Harry Villana Isis. Contraption. Thank you for joining me. So yes, I fully recovered from my little bout of whatever it was, and I took the pleasure of visiting Jan Rack and taking some images, some of which I have shared videos of these kind of arcs, and thank you very much Vanilla Isis for that $10, very kind of you. I shared these images, and then Bernai shared a video with me of one Sean Calderon. Sorry for my calling him Joe earlier, Joe Blogs or whatever. I couldn't really work out who it was from. But anyway, I think essentially what you're seeing across the two on the macro scale is a difference between frequency and potential. There is one key difference as well between the two coils. On the left, the electrode here is a tungsten welding rod, and over here, if I am to believe correctly, and maybe Bernie could confirm, this is actually a silver wire coil, and presumably the end of the silver wire is coming up here, so this is silver. Okay, of course the atomic number is very different between them, and they have key properties like silver is diamagnetic and tungsten is paramagnetic. Obviously the conductivity of silver is the highest conductivity, but tungsten is one of the most conductive elements, and often these tungsten welding rods, I don't know in this case, but they are doped with things like thorium or cerium to massively lower their work function, so they may be better at doing space charge based exotic vacuum object launches given a specific impulse. And so essentially what I'm saying is, and I'm no expert in these coils, I just want to say that right up front, and there's probably people in the chat or that will look at this video and think, what an idiot, he doesn't know what he's talking about. Now that may be true, but my intuition is, when I see these things, and I've studied this extremely high fidelity sequence here quite a bit now, and when I do further studies I will change the iris and so forth on this so that we'll be able to look deep into the plasma rather than it blooming out. They are largely the same, except the number of tendrils you see reaching out are much higher in this, and the twist is much higher. And this, in my view, is aligning with there being a much higher potential and a higher frequency. And I imagine if you dial down to either the potential or the frequency or both in this situation, you would tend to this sort of thing. And then if you did it further, you would end up with just one of these kind of like rotating type of flames. I do know in Sean Calderon, experiment, he had a conical coil, and this I think was even on a pyramidal structure. Maybe it wasn't this one, but whatever. These kind of discharges are largely nitrogen is giving you this color here. Of course, nitrogen is 78% of the air that you breathe, and as far as I know it, Sean was doing a discharge into straight air. We know for a fact that Jan Rack was doing it into straight air. Okay, so with David Boutlier's device, and he has a corona ring around here, you can see the discharges coming off, and again it's the same kind of purple you get from nitrogen. Of course, within this tube here, the desmetron of Griffin Brock, this is not purple, and therefore we can reasonably safely conclude that the gas that is in this tube is not nitrogen. Okay, so there we have that, and there's this rather lovely video of the discharges going on here. Now, what I want to do in this video is I want to look at the thermal imaging that we did of the Jan Rack device. And this particular discharge, it's fairly flexible. You might notice he was changing the pulse rate. I'm sure he can change the potential on that. I'm going to learn a lot more about it. And I learned after using that thermal imaging device for the first time that the inbuilt software only records at 9 frames per second. And given the fact that it's already, when it's at 25 frames per second, which you see on the screen, 5 frames behind the original discharge, and given the fact that the discharges are so brief in their duration, it misses a lot of discharges and in terms of what is recorded, and you might actually see 2 separate discharges recorded in the 1/9 of a second, or rather, yeah, in 9 frames a second, you might see 2 different discharges go off. So I found a workaround with some screen recording software, and so we'll be able to use that and also register the 2 images simultaneously. So we'll have a much better idea moving forward. But even though it was so poor, we can still learn a huge amount, in my view, from what was captured. And I think it speaks to what is actually going on. And I think it's really rather exciting because it's kind of falling into place with our other understanding. We have another opportunity, of course. We've still got our PI 160. I need to find a calibration file for that so that I can use that. That actually, although it's only, I think, 160 by 120 pixels, it does run at 120 frames per second frame rate. So that is really good because the images that we were taking were also at 120 frames per second. So this means that if we can do this right, we might be able to capture, albeit lower fidelity, thermal imaging, but at the same frame rate as the video images. And because it's a separate camera, we can move it around and also get those relatively aligned. My challenge with that, other than getting the calibration file, is at the moment we have a 50-degree, I think it is, field of view rather, on that lens. And I know we can get tighter lens attachments. I hope they're still available, because I think that whilst they've changed the cameras, and the modern Optris cameras, I think they only do 80 frames per second peak on the more expensive ones. They're actually a higher resolution, but only 80 frames a second. So I actually like the fact that ours does 120 frames per second. And it can also look up to, I think, 1,550 degrees centigrade. So it's got a very wide range of temperatures that it can work over. But if we can get that working, and by a tighter field of view, it means that we can have the camera at a reasonable distance away with the optical camera at the 4K, 120 frames a second, 300 megabits per second, no artifact, 10-bit 422 capture, and have the thermal imaging with a tight field of view. So it is going to give us some really good understanding. But I think it's one of these 80-20 rules, like possibly with just 20% of the data that we could potentially achieve thermally, we might even get 80% of the learning. And so let's see if that is the case. Okay, so just some a little bit further on the Sean Calderon discharges here. You can see them fanning out, and you can imagine that the electrical discharge coming up here, this unipolar. What do I mean by unipolar? Well, there isn't a counter electrode, and normally when you research unipolar discharges, they're referring to things in tokamaks where a instability in the plasma, which in my view is an exotic vacuum object, goes its own merry way and collides with the wall, which is often made of tungsten. And I'll show you an image of that in a minute, which I've used in the past, but I can just go and find it. It's very easy to find on a Google search. It actually hits the tungsten and branches out and leaves a beautiful sort of snowflake type pattern on the tungsten. You can also get trails of these unipolar arcs, but they're the ones on the impact side. This is on the emission side. Okay, and you can imagine that these filaments are moving apart based on the magnetic field that the discharge itself creates. So it kind of pushes it in different directions. I kind of like to think about it in a different way, and I'd like you to consider my thoughts on this, that the space charge around the emission electrode allows for exotic vacuum objects to form, and they get overexcited, and at the point of breaking away, they split up into a number of fragments that go off in different directions, and they form the initial discharge channel as described by Ken Shoulders, and then other ones that come behind follow them. And these kinks occur because the plasma itself is being distorted by the magnetic field that is created by the discharge as it progresses. Okay, so we've got a whole bunch of these here and some more here, and that's that. So I'm going to go now to the videos, which I hope I've got reasonably accessible here, and we'll go through the videos of the thermal imaging, and there's a couple of things that I think we can get out of that. So give me a second, I need to open up Premiere. I don't know if people caught it, but I will be presenting, I've announced my presentation title for Cosmic Summit 2025, and you can get tickets for that, all but one type of ticket with my unique code of Tesla. So I would encourage you to come to that, and I will be talking about annihilating space and time. Okay, so Premiere. Dum, bum, bum. Okay, hopefully it's going to find all the source files. If not, that's going to be upsetting. Okay. Yeah, just first up, because it's a bit of fun. This was my solving the syncing problem and getting 25 frames per second out of the thermal imaging camera. So the thermal imaging camera is on the left, and It's auto scaling actually. It can actually go from up to 550 degrees, I think. It's a little bit annoying because it seems to do some sort of recalibration every sort of 5-10 seconds, and it loses a whole chunk of frames in that time. I'm hoping that that isn't a problem, and I would prefer to be able to specify a temperature range or fix a calibration or whatever. So it's a problem I need to solve. However, you can see here that we've got plenty of frames and it's in sync. There's my foot. You can see the foot. And this isn't actually the camera that it provides. This is a camera that has come from the screen recording software, and I'm able to merge it in, and then in Premiere I'm able to shift the 5-frame delay out of the way, and also allow for the recording of audio, which is useful for syncing stuff up. What I found was quite amusing is that the floor here is at 19.5 degrees. Of course, my body is at body temperature, but leaving my foot on the ground is sufficient to raise the floor temperature at the hottest point that it's identified here to 23.8 degrees. So it's raised it by 4 degrees. And even just putting it down for a very short period of time, you see the hottest point on my foot is 32.1 degrees. If I move my foot away in a very short period of time, again, it's raised the floor temperature by nearly 3 degrees. So if you want to track someone who's barefooted, this is the tool you would use to do it. Not that I'm promoting that. Actually, the camera kind of, my rough jerry rig fell off at this point. So it definitely needs to have something a little more solid. Later on, it just occurred to me that I could actually write on the wall, so I decided to write the word Zeus. And that just goes to show you that even though my finger here is only at 24.1 degrees and the wall is around about 20.2, I was still able to transfer enough heat very, very quickly onto the wall, enough to write that and leave it and be able to be caught on camera. Of course, if the temperature of the wall was colder and the writing implement was higher, then it would leave that signature there longer, of course. So because it's a function of the temperature differential, Carnot cycle and all that in generation of power. This is going to become relevant for what we're going to see in the video that I took of the unipolar discharge, the so-called dragon discharge. Okay, so that was that, and I will find now, that's that one. Okay, so have we got it here? Has it got it here? Oh, come on, find it for me. Okay, all right, so I have it here. So hopefully we can find some useful frames here and I can zoom into them or whatever is necessary to be done. I would have liked to have marked some up, but I didn't. So I'm going to have to go through it. Okay. So for those that don't know, there's a kludge for YouTube. If you've got 120 frames per second video and you want people to be able to see it at 120 frames per second, well, YouTube is limited to 60%. 60 frames a second. What you can actually do is in Premiere or whatever, you can slow down your video to 50% playback speed. You can then upload that as a 60 frames per second video, and then the viewer that has 120 frames per second phone or screen on their laptop or monitor or whatever on their computer, they can then play that video back at double speed on YouTube and actually see the 120 frames per second real time. So that's what I did for you guys in these videos. And that's what I would do moving forward for 120 frames per second discharges. So we start off this video by looking at it with normal optical with the light in the room turned on, and then Yang turns the light off. And the very first thing that I noticed here was, well, you have to take the colors that you see here with a little bit of a pinch of salt. Why do I say that? It's because the emissivity of the camera, which you can see down here is at 0.95, is not correct for every surface that you see in the plane of view. So people often make the mistake of getting a thermal camera out and believing that whatever they're pointing out at, that's the actual temperature. But the emissivity of, say, alumina, of skin, of fabric, of the tungsten, of the ceramic, of the maybe the Kapton tape or whatever that's covering these parts of the Tesla coil here, they all have very different emissivity, okay? Very different emissivity. So you cannot say that this necessarily is much colder, the Tesla coil here, than the background plate, okay? It certainly looks like the coldest thing in the room, 17.9, but it might be because there's very low emissivity of that. The way you get round this, would be to paint everything with the emissivity of a black paint. And we've used this in experiments in confirmation or testing the claims of one Andrea Rossi's Hot Cat way back in the day. So that is commercially available. So if you want to actually know how hot your temperature of your Tesla coil is relative to your tungsten rod and whatever, you can paint it with this paint. And the paint is good up to about 1,000 degrees centigrade, maybe even a little bit higher, some of these paints that you can commercially buy. And so that's that. Anyway, what we can be sure, I believe, is that the hottest part in the frame, which it's identified here, is 74.1 degrees centigrade. So that is the tip, the tippity tip here of the, can I move around this? It's not going to be very helpful, is how I do that. It is the tip of the tungsten filament, okay? This is actually a rather nice image that we're seeing here. And why am I saying that? I'm saying that because it has this arc over the top. Now, you're not seeing it here. Again, this is a frame mismatch, but don't worry about that. The first thing that we can learn from this is that okay. So before I say this, I need to have a proviso. The accumulation time for getting the thermal temperature is very, very short. 1. 2, if a discharge is coming towards you, you're going to be seeing through more plasma, so you're going to have more thermal photons coming towards the camera. But that being said, the green is down this end of the thermal spectrum, the yellow is in this end, and then the red is up here and the white is up here. And as I stepped through this, what I noticed was where it was more kinky, that is to say where there was more distortion in the discharge, it seemed to get hotter. It seemed to get hotter. And when it got really hot, it would appear to be where the branches are. Okay, and this might be a good example you can see here. Possibly it's not the clearest thing. I'm going to see if I can actually zoom in and move around. Let me see. I'm going to go 100% here, and then that's the only problem is it's not going to let me do that, is it? Is it going to let me do that? It's not going to let me do that. You know, I used to be able to just press the... This is the useful part of the frame anyway. Okay. Right, can you see that? So hot bit here, and then we've got another hot bit up here, and I just wish, oh dear, I should know what I'm doing here. Can anyone remind me how I pan around this? Because it's not allowing me to pan when I stop it, when I touch it, so that's tedious. Anyway, we'll do it like this. This is not ideal. I feel like an idiot, and I'm not, but I'm being an idiot right now. Oh, come on! Helpful things to move your screen around. Okay, so the other thing is that you can see immediately after this discharge that there is a drift in the room, and you can see warm air is moving away to the right. So this supports the notion that this area over here was hotter because you've still got this warmer area moving across here. Now, someone shared with me this acoustic system where they argue that the channel of air through which the discharges occurred can be prevented from moving using an acoustic array, and by changing the central node you can actually shift that around. And I shared that with Jan Rack almost immediately, and so he is in the process of building a guide, and this will help with later experiments. So we should be able to force the discharge into a particular place, which means the tippity tip of the discharge we will be able to guide to a target and be able to do work in a more precise way in the experiment. Okay, so that's one thing. And then as we go on through this, again, look, you can see it must be hottest here at the point of the major discharge here, okay? And certainly the tip of the welding rod is there. In these kinky bits, the really kinky bits down the bottom, it's getting up to the hottest bit. And then it goes all the way up here, and then we have a hotter spot here and a branch coming off here. Let's see if the pattern repeats itself. Okay, so this is really kinky here and it's getting hot. Again, we have a kink here and we have a branch coming off. We have a deep bend here and it's hotter. Is it just because we're looking through more material? I suspect not, and I'll go forward with my argument in a little bit more detail as to why I think. Again, we have a thing that's really kind of kinking up here, and at that point it then produces another arm. Of course, we got it down the base. Again, we have a hot bit here and then it's branching. Again, a hot arch here. Now in this case, we actually have this pretty much in sync, it would appear. And the good thing about this is we know we're not looking through too much of it. It's not coming towards the camera. It's going a little bit away, but it's on that bend where we've got this hot area here and it's starting to branch out. Now, I've argued many, many times that I believe the branches in ordinary lightning, which is quite similar to what you saw on David Boutlier's discharges, again, hot spot kind of branching going on, is, in my view, where you get a cluster building and it gets overbuilt and it's then compressing in. That would pull push the temperature up and up and up. But of course, if it got too intense, it might break and fracture. And then what I believe you're seeing is the splitting in the forking in the lightning. Okay, so you have a kind of an EVO coming down and it gets overly energized, it self-energizing as it goes forward, and it kind of like then breaks up into two tendrils or multiple tendrils. Okay. Okay, so again, here we have two kinky bits and a branch is coming off. Now remember what I said, the space charge, that's the amount of charge in a very small space leads to these self-organized structures and their ability to launch off. Okay, again, hot spot here and definitely a branch going on. I think after a while you're going to get the idea. This is my hypothesis. And okay, so we have a hot area here, branch here, hot area here, branch here. Remember what Ken Shoulder said, electronic structures built at electronic speeds. So it's sometimes, yeah, there we go. We've got all kinds of kinkiness going on here and it's hot. Now, this is the interesting part here. You don't see the discharge, but this spot appeared on the frame. And as we step forward, and bearing in mind the center of this spot is white hot, it's right at the top end, and so is the outer boundary, and then there's the torus-like structure here. Maybe you can't see that, maybe I can get in a little bit closer. There we go. All right. Do you believe me now? And then this structure there stayed for a period of time. If I step forward here, there we go. And you can see heat rising. The central spot where it is not moving. I'm moving my camera. So the lateral movement, in fact, most of the movement here is my hand. I will have it on a tripod next time. And we're looking over, each one of these is 1/6 of a second apart. So it's actually lasting for quite a long time. And in fact, it's lasting for a good number of discharges. So I'm going to zoom back out of that. And the other extraordinary thing that I noticed, extraordinary to me anyway, is that subsequent discharges were attracted to it. So let's go back. Not all of them, but some of them. Okay, so it hasn't gone there. It hits it and it appears. And then as we go forward, 6 frames a second. Okay, come on, here we go, here we go. Right, so this discharge appears to be attracted to it. And this is unfortunate that we don't have 25 frames a second, because we'll have again, this discharge appears to be attracted to it. This one, maybe a sub-branch is going over to there, not conclusive. This one appears to be attracted to it. It's very persistent here, very persistent. Again, this discharge appears to be attracted to it. Again, this one, dead, like that, all of the discharges just going to that spot. The weird thing is it's not actually making it hotter. It's kind of like, it's just pulling it towards it. Again, is this moving towards it? Maybe. If only we could actually get a better frame rate. It's going to happen. We're going to see it. But like it's a 80-20 thing maybe. And I'll just play this out because there's another one that comes in here in a second. And it goes there. It's not as good, not as big. But some of the other discharges are still going to this spot. There you go. You just saw two in fairly quick succession. I'm rewinding now, so I'm going to rewind. Look, that one. Clearly, vortex all the way down to that particular spot. Now, And look, these several discharges going in a row. So here, that one is definitely going to the spot. The next discharge that comes along, again, definitely the tendril is being attracted. This going over here, but this one is then emerging and going up to there. And then, wait for it, another one. There we go. So even though it's practically died, there is something there that keeps pulling in. Okay, so what do I think this is? I'm going to get my prop. So, when our EVO here launches off our, our electrode, so imagine my water bottle here is the top of the tungsten filament, and we've got our EVO coming along here. There is, because of the high frequency discharges, there's going to be a lot of EVOs following behind it. But what does the EVO have behind it? It has this cone. Okay, it has this cone. It's feeding cone. And what that's doing is, as far as I'm concerned, if you consider my chest here, the black fabric that you see there, it's hit that black fabric, and the cone is stuck coming out of it like that. I've been got by that, right? And I think what's happening is this is sending out a spin vortex in the ether, and if anything's close, it gets pulled in. Okay, it gets pulled in. Right? I think that's what's going on. And so I proposed to Jan Rax several tests for this. The primary one is to maybe get some pure alumina or other refractory non-conducting ceramic. Put a rod, have a heat tape, and have a rubber handle, and see if you heat up the end of that ceramic, whether you can place it and then whether it is attracted. It may actually be the case that the heat radiating from that point is lowering, or rather increasing the pressure in that, whatever, the thermal photons coming out are sufficient to encourage the discharge to go in that direction. That's one way of thinking about it. Or could it be that it is the latent EVOs, the cooled EVOs that are still, or energy solitons? Because if we are to believe Alexander Shishkin, the types of discharges that you're seeing in this dragon discharge will be producing vast numbers of energy solitons, high energy solitons, and they will cool. And the theory is that if you have another pulse, they will break up and they will become medium and low energy solitons. Okay, if that is the case, then this sound field, and the hypothesis with this sound field was, and one is quite reasonable, that you have partially ionized air, and if you confine that partially ionized air or that higher temperature thermal channel, the discharge will tend to go through there. But what if there's actually a whole bunch of energy solitons that are in that air, and that is the most desirable way for the discharge to travel? Perhaps that's it. Perhaps that is it. Of course, the air itself already is replete with medium and low energy solitons, but you would imagine that the discharge channel would be a little bit more excited than the average ambient air. But it is my belief that what we are seeing in that series of the discharge, with these whole bunch of ones here, I mean, if I just play it back, it becomes pretty clear. I'll go back to when it starts. And it's weird because it's kind of almost as it's nearly completely cooled off. It's almost as it's nearly completely cooled off. So we'll start at the beginning of this little section here. There it is. And 1, 2, 3, 4, 5. And then a whole pulse of them here at the end. It's still going to that one. Now, we were trying to work out what these were, and then we noticed that if you look on the back wall, when the lamp is off, as it were, or rather on, there are these marks. And I suspect that if we look at these marks, we are going to find yeah, sorry, I wasn't showing it, was it? Sorry, that's my bad. I'll rewind that here. Okay, so I think what we're going to find is that on this back wall here, where you can see these kind of like slightly different colored marks, we are going to find transmuted tungsten. And so, we are going to do an Alchemy of Prague in September. It will be with myself, Paul Harris, Roger Green. We will do a full day mushroom foraging, which I'm really looking forward to. And we will do a full day in the Elia Foundation, Jan Rak's facility near Prague. And it is my proposal that we use this device to 100% and categorically prove transmutation for the attendees. How do I suggest to do that? Well, if you recall, we used HHO on a tungsten welding rod, not dissimilar to this one, okay, in Japan in 2019. And that is where we saw the magnetohydrodynamic structure with a little ball, and it helped us define the overall structure that does this magic. In that sample, we found that every single transmuted area had calcium in it. You can go and look at my poster presentation from ICCF 22 in 2019, where I share that. I've shared it many times since. And the sister product to that is xenon. Could that be why some of the flashes here are so white on this Jan Rak device? Maybe, don't know. But obviously xenon, for those who've got car headlamps, it's pretty white. So what I propose is that we have a witness material. Ideally, it would be some tungsten foil, but let's say that's expensive. Let's take some, for instance, copper foil. Copper is a good contrast medium. You can get it in very pure form. It's one that was used by Takaaki Matsumoto very, very effectively. And if we identify through some thermal thing that it's attracted to something thermal, or it's attracted to something magnetic, or it's attracted, or we can force it using the sound field, then we can target a particular area. Now, Jan does this and allows people who are visiting to put their hand and allow the discharge to hit their hand. Okay, and it does, very much like a plasma globe does. Of course, some people think that the plasma globe, the filaments are attracted because of capacitive nature. Other people think it's just the thermal effect. It could even be because of the EVOs that are streaming out of our fingers, allow for some sort of reconnection to the brush filaments coming from the plasma globe. Whatever. It does get attracted to the hand, but we're not going to be putting our hand in the SEM unless someone's willing to do that, and that's not going to happen. So I'm essentially making another announcement here that Jan Rak will be buying, in, as far as I understand it, the so-called MFMP SEM EDS that we have all seen some beautiful images from over the last 3.5, 4 years. So that will be located there. So, and we will conduct these experiments beforehand. And so what I'm proposing is that we get witness material plates, we do that discharge, and we see on that plate an impact mark. We literally take that plate. So the ideal thing would be someone comes to the day with their own welding rod and their own pure 5/9 copper plate. And we cut the bit of the welding rod so that it'll fit in the SEM, and we look at the tip that's going to be the launch point for the exotic vacuum objects. Right, done. It's just tungsten, small amount of carbon and oxygen on there, maybe some thorium or cerium or whatever it is that is the low work function component. Okay, we then put that in the top of the discharge unit. We then take the copper, we put that under the SEM. It's pure copper. Right, excellent, fine, done. What other elements have we got? Well, we've got nitrogen in the air, we've got water vapor in the air, and we have oxygen, predominantly with very other minor components. Put that copper plate, discharge to it, take out the electrode and the copper plate, put in the SEM, and I predict that we will see calcium. I predict that we will see calcium. Of course, I have given many examples of transmutation and disappearance of tungsten in various experiments. I'll reel off a couple. Irving Langmuir observed a 7,000 times production of gas in his tests with tungsten in his filament light bulbs in the 1910s. David Hudson in 1980s blew up 2 thumb-sized electrodes in a furnace trying to test ormus. Interestingly, outside of that device, past where he was standing on the back wall of the lab, there was glass containers that disintegrated. I think also some insulation on some wires. He thought it's probably not good to keep blowing up these tungsten electrodes. The highest COP by Tadahiko Mizuno was 800 times, and it was with a tungsten filament in the mid-1990s. There is another example of tungsten disappearing in the sapphire experiment. If you remember, they were trying to determine using a Langmuir probe the temperature or electric field gradients in double layers, and as they put it in within one frame of a video, it disappeared, and there were things that looked like EVOs flying around in the chamber. That was a $7,000 or $11,000, I think a $7,000 problem for them. So we have also observed the disappearance of tungsten and ball lightning being made on a coil in a Henkurian-Vega experiment. And the ball lightning forms, and on the double layer of the boundary of the sphere, it cut the tungsten clean. Okay? So tungsten, I've said for a long time, is a very good Lener fuel. And in fact, I predicted it was in Sapphire/Orion Energy's system because of the products that were synthesized. And it turns out in their patent, it is a key part of the fuel. Okay. So tungsten, the most likely, I could show you it. I could go to the MFMP's Lener reaction calculator programmed by Philip Power, based on work by Alexander Parkhomov. And you would see that the most common isotopes of tungsten lead to I think it's like 54% of tungsten will lead to the production of isotopes of calcium and xenon. So, if we prove this, then this will be an experiment that can be conducted at will, 100% of the time, to prove transmutation. Prove transmutation, and since we know that it's being caused by exotic vacuum objects, we will know 100% that exotic vacuum objects can produce transmutation. Done. We can forget about it. It works. Let's move on. Okay? I'd also like to do a test where we do what people do with spark plugs when they do these plasma spark plugs. And that is, and I've suggested this to Jan already, spray it with a mortar mister or use a pond fogger or a humidifier in one of these ultrasonic water mist generators and see if that will increase the intensity of the discharge and any increase in the rate of transmutation. Why do I say that? Well, it will be creating HHO. That is the stuff that we made those transmutations with in Japan in 2019. Okay? So we will be increasing the humidity in the air. Then I will suggest, and I'm suggesting this to Jan, which I have not done yet. I'm doing it, and I think he's watching now. We actually take that tungsten filament that is coming out, that you see, if I can arrange it correctly here, if I can get this actually doing something useful. Fit, okay. This tungsten filament here, okay. And what I would like to do is get effectively a fishbowl and put a fishbowl like around the tungsten filament. And what we'll do is, the idea is to have this fishbowl coming around here so that all of the typical discharges will be included in the fishbowl. And we evacuate it through, he has some incredible vacuum pumps there. So we evacuate it and then we introduce a little bit of water. So the inside this sphere will be basically water vapor. Okay? And that is a source of hydrogen. And we know that hydrogen is 2,000 to 4,000 times easier to produce energy solitons, which are exotic vacuum objects, which are magnetotoroelectrical radiation, which are blah, 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 according to Shishkin, Karolz, and Dubovik, the sadly departed Dubovik. So will it increase the effect? I don't know. It will effectively be a bit like a plasma globe. But here's the thing. I want to see if we are going to get xenon in there. So we run it for a period of time, and then we extract the gas, and I could either ship that over to Alan, and we can test it on the mass spectrometer, quadrupole mass spectrometer in California with my colleague Alan Goldwater. Or we can take a sample of that gas and put it into a gas tube and excite it and see if we get the spectrum of xenon. If we get the spectrum of xenon and we have 100% repeatability on the synthesis of calcium, where there is absolutely no xenon and absolutely no calcium in the system, then we will have 100% proved the fission of tungsten using space charge, exotic vacuum objects, and hydrogen, oxygen in an environment. So from my point of view, this is an absolute winner. We have a lot of history to show that this is going to work. And I think it's going to work. And if it does, we'll know long before we do our Alchemy of Prague. And those people fortunate enough to be there will be able to witness transmutation, 100% certifiable in literally minutes, repeatedly. Okay, so now why is tungsten so important? Well, let's go back to where we were here. And I've got a summary of our observations here. So the observations were that in the first thermal imaging of unipolar dragon fractal discharge was that the branching was at hotter parts of the discharge channel. And I believe this is where kink instabilities are forming and they're leading to other exotic vacuum objects and they are breaking away. And I'm going to give some more detail on what I think is happening there. The thermal channel of the arc is visible in the air after discharge, and we're going to be able to resolve this much better with potentially the PI 160, but definitely with the the system that I have, the IC, with 25 frames a second. The persistent impact-related spots on black fabric attract subsequent branches. So this is all very exciting to me. Now, do I want to do this next bit first? Now, the other thing that is curious here, to me, is these curves. And Jan seems to think this is a phi ratio curve. And there is no real curve here. Is it because of the length? Is it because of the intensity? Is it because of the frequency? I don't know. I don't know. However, we're not seeing much curve here. We're seeing kinks and we're seeing breaks. I think potentially the curve here could be something to do with the structure of an EVO. And of course, we know there is phi ratio in the EVO all over the place, but I don't mean that. I don't mean that. Something to do with the structure of the EVO and the element used being tungsten, and in this case silver. And I think in this case this is an aluminium torus here for this corona ring. I don't think this is a torus made of tungsten. I think it's a lighter material. Okay, so if that's the case, then this is heavier. Now, what did Ken Shoulders say about how to make stable exotic vacuum objects? He said you need high Z, that is heavy elements. And typically, he would use a tungsten tip electrode and he would wet it with mercury. Tungsten, mercury. Two heavy elements. Okay, the mercury would be a self-healing electrode. It would form a tailor cone, very fine spike, so really good, intense space charge around that for doing the launching of the exotic vacuum object, and then it would come back and heal. Okay, heavy, high Z material. Why is this important? Well, Tesla used in his 1935 electrical particles of matter gun, as I understand it, either tungsten wire coming in or mercury. Not a combination of the two, but this produced stable, what he called electrical particles of matter. I have a PDF here of his comments on this. So this is from 21st Century Books here. There may be people that know more about this than I do, but I'll read what it is attributed to him circa May 1935. Briefly exposed by Nikola Tesla. The advances described are the result of my research carried on for many years with the chief object of transmitting electrical energy to great distances. The first important practical realization of these efforts was the alternating current power system now in universal use. I then turned my attention to wireless transmission and was fortunate enough to achieve similar success in this fruitful field. My discoveries and inventions have been employed throughout the world. In the course of this work, I mastered the technique of high potential sufficiently for enabling me to conduct and operate in 1899 a wireless transmitter developing up to 20 million volts. Sometime before I completed the possibility of transmitting such high tension currents over a narrow beam of radiant energy, ionizing the air and rendering it in measure conductive, after preliminary laboratory experiments, I made tests on a large scale with the transmitter referred to as a beam of ultraviolet rays of great energy in an attempt to conduct the current to the high rarefied strata of the air and thus create an auroral such as might be utilized for illumination, especially of oceans at night. I found that there was some virtue in the principle, but the results did not justify the hope of important practical applications though. Some years later, several inventors claimed to have produced a death ray in this manner. While the published reports to this effect were entirely unfounded, I believe that with the new transmitter to be built, this and many other wonders will be achieved. Much time was devoted by me to the transmission of radiant energy in various forms by reflectors, and I perfected means for increasing enormously the intensity of the effects, but was baffled in all my efforts to materially reduce dispersion and become fully convinced that this handicap could only be overcome by conveying the power through the medium of small particles projected at prodigious velocity from the transmitter. Electrostatic repulsion was the only means to this end, and the apparatus of stupendous force would have to be developed. But granted that sufficient speed and energy could be realized with a single row of minute bodies, then there would be no dispersion whatever, even at great distance, since the cross-section of the carriers might be reduced to almost microscopic dimensions, and immense concentration of energy, irrespective of distance, could be attained. Okay? The problem with using heavy elements is it produces dirty etheric matter rays, and you can't fire those through a closed tube. So he had to produce this open-ended tube, which I showed here. And he used compressed desiccated air or dry steam, and it came through here. The electrical particles of matter were launched and charged from this electrode through here and went through the dry steam and out into the environment. Okay, that is different from the desmatron, which was his basis of his shadowgraph, which in this case is using aluminium, and aluminium produced and was verified to produce by Tesla clean etheric matter rays. And the claim of Griffin Brock is that these are being able to be transmitted up to 1,000 feet, according to David Boutlier's account. And we are testing that in order to do a method of scanning the Great Pyramids and similar objects that might be of interest, okay, by using that technique in shadowgraphs using drones. And that work is ongoing. Okay, so, but here's the thing. These etheric matter rays, in my view, are the same as is being produced by the Podkletnov device. His is much higher tension. So he launches his etheric matter rays at much higher tension, and so it is observable from 5 kilometers away and passing through matter. So now, when I'm putting these thoughts together and trying to explain the curve in that, I'm thinking, well, are we looking at something like Eric Lerner's kind of plasmoid model, which I have an image of here? And I don't believe the structure is like this, but that is Eric Lerner's plasma fusion model. But what I do believe is interesting here is that negative particles are coming out one way, and positive particles are coming out the other way. Negative particles coming out one way and positive particles coming out the other way. And so this gave me an idea for what might be causing this. What I believe is causing this is that at the kink instabilities, exotic vacuum objects are forming, and one direction they are shooting out electrons, and the other direction they are shooting out ions. In this case, the ions are extremely heavy tungsten ions. So you've got positive things coming down here, but of course this discharge is negative. So the negative discharge is pulled towards the positive structures that are coming out. And they're coming out all the way along here. So I don't know, it's not a perfect idea, but this is something that I'm asking people to consider, that there might be an influence on the charge. And to that end, I found a scientific paper that argues something along these lines, and it's called Electron Kinetics in High Z Plasmoid. And it's saying here, the problem of the electron dynamics on a closed magnetic field line passing through high Z plasmoid is considered. The electron kinetic equation is integrated over bounce motion and pitch angle, reducing the independent blah, 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 blah. Essentially, it's talking about plasmoids, which we know are a name for exotic vacuum objects, and it's talking about how things are trapped and how they're affected by high Z. But here is the key phrase, which I think aligns with what I'm trying to get across here. Plasmoids with high Z ions expand more slowly along the field lines. That is very important, because an exotic vacuum object and even a smoke ring becomes weaker as it dissipates, as it expands. If it's pinched in, then it's more stable. So the observations of Nikola Tesla to use mercury and tungsten, and the observations of Ken Shoulders and claims that high mass elements are, and in fact, what actually Tesla did is he used a mercury wetted tungsten electrode launching into, drum roll, xenon gas. So he actually had a heavy gas that he was launching that into. So all the ions were heavy. So what it's suggesting here is that the plasmoid expands more slowly because of high ion mass, but it also introduces strong pitch angle scattering of electrons. So I believe that what you are seeing here, this curve, could be to do with the type of metal that is the source of the ions that are stabilizing the exotic vacuum objects. Okay? And in the case of this one, it may not just be because of lower frequency and lower potential of the discharge. It might actually be because they are silver ions that are coming out here and not tungsten ions. And if I'm correct, and we observe xenon, this will actually have tungsten and xenon ions in its discharge. Tungsten and xenon ions in its discharge. So it will be interesting to see at the same frequency, with the same impulse potential, that if we change this electrode, what kind of changes we get to see on the discharge. So this is yet another experiment that I would like to do with Jan Rack. Another experiment to do with Jan Rack. Okay. So essentially, Ken Shoulders stated that heavier ions made more stable EVOs. Tesla's electrical particles of matter gun used mercury or fed tungsten wire, and Ken Shoulders' exotic vacuum object gun used mercury wetted tungsten wire. Heavier ions, that is plasmoids with high Z ions, slow expansion, and they introduce strong electron pitch angle scattering, affecting internal dynamics. Okay? I think something like that is going to help us understand why we get these kind of structures here. Okay. Right. I think that's probably enough on that part of it. Are there any questions at this stage? Ken Pratt, Bob, I have a bunch of manganese, which is very heavy. Well, manganese is nowhere near as heavy as mercury, xenon. Might be, no, I don't think it's as heavy as xenon or tungsten. It's the heaviness of the ion. The other thing is that between these two experiments, as I said at the beginning, these silver ions, both isotopes of silver, are diamagnetic, whereas the ions here in tungsten are paramagnetic, which means they may behave differently in the discharge in something that's very magnetic, as it were, the actual discharge. Martin, could it be chemical reaction? If we see calcium in the impact from a tungsten electrode going through essentially 78% nitrogen, 20.85% or whatever it is, oxygen, and trace amounts of argon and whatever, and it's hitting a 5 nines copper plate, and we see an EVO impact mark, and it has calcium in the usual places. No, it's not a chemical reaction, not even slightly. Three says, Bob, do you think this structure could be a type of representation of the Assyrian tree of life? It's an interesting thing, but maybe no. I don't think so. No, it's an interesting comment though. Thank you. So Crypto Alchemist said, I found in my electrochemistry that the heavier elements, the more isotopes are formed, and the more reactions of decaying elements break down from the anode. So Crypto Alchemist, Piantelli said, I don't use palladium because palladium's got so many isotopes. It becomes impossible to understand which way it's going. Nickel's better from that point of view. So yeah, you're going to get more from more isotopes, of course. Depleted uranium would be a particular thing you could consider. It did cross my mind earlier today, Gordon Doherty. It did cross my mind. Yes. It would be worth, I think, giving it a go. And with depleted uranium, would we see a higher pitch? Is there a constant? No, there isn't. No. I think what's happening is you get a large EVO formed on the end here, and it breaks up just like I'm saying you're getting branching in lightning, which probably this is a better example to look at. And it does seem that the beauty of Sean Calderon's work here is that you can really see that the beam comes out of part of the twisted structure. So here it's twisted and then it's tying itself into a knot as it's going up. But there's less chance here for it to do a full kink, whereas you can literally see on this, it really is very kinky. Oh, there's lots of, not astrology, but astronomy, there's parallels, Martin. One of the things we're going to do is film from multiple angles so that we know exactly when we have a discharge that is perpendicular to the camera's lens, so that then we can do better understanding of the curvature. Okay. Okay. So I want to go in a completely different direction now. So the experiments I'm suggesting is testing on a target. So that is different targets. So to see whether if you use a ceramic rod that's been heated at one end, will that attract the discharge? Okay, so let's see if that works. Then tests for transmutation, as I've described. Then enhancing the process by adding water vapor or mister. And then the last one would be to put it into a globe, evacuate, add a particular gas, but my preference would be water vapor, water gas, and then do discharges and see if we synthesize tungsten. This is something we couldn't do in, synthesize xenon. It's something we couldn't do when we were in Japan. One, because we didn't know it would do any transmutation at that point, and two, because we didn't have any means to test gases, and we couldn't capture it. It wasn't necessarily an expectation down there. We're not the only people to see calcium synthesized from tungsten. It's not a first, but to be able to do it at will and on demand in minutes, and to be able to show someone bringing their own samples in and have transmutation. And it's not just transmutation on the end of the thing, because everyone says, oh, it's contamination. Where you actually see the strike hit the copper, you then look at the thing where the strike is, and just like I did with the face mask before they were fashionable in 2019, we had Dr. George Eagley. I said, look, put it over the end there and use the vacuum cleaner and suck in the particles. We literally had all the same transmutation products on the particles that were grabbed in the face mask filter alongside literally physical chunks of tungsten, right? And no one buys a Japanese face mask and takes it out of its package and expects there to be lumps of tungsten embedded into the fibers. It's just absurd. Like, you literally take it out of its package, tape it onto the end of a thing and start sucking, and you're getting the transmutation products plus the tungsten. I expect to see the same kind of thing on the impact marks. Okay. So, yeah. So I think that what I've learned from this, and I just want to share this with you now, is what I think is coming out of the top of the EVO is a coherent matter beam of energy solitons, which will be a vortex and maybe neutral. And this might be what we have seen causing the spinning round of other structures that are coming from a different angle in the David Boutelier-Vega experiments. We do know that everything gets pulled into the back of the EVO as it's traveling in this direction. And we do know that when they die, they spit out all of the matter that may be in a coherent state in the core out back this way. So we do know, at least at some points, they do spit out ions and or resynthesized matter. Okay, so this is not too far off the mark in some respects. Okay, so what happened was, when I was initially thinking of putting this presentation together, I looked at a whole bunch of previous presentations I'd done on tungsten transmutation and so on, just to build the argument for, I expect this to be a slam dunk 100% certain transmutation thing that we can do at will. And I came across work I had never seen before. And then I read it and I was blown away. So I'll leave a little pause here and I'll go visit the boys' room, and then I'll be back with some very interesting material. I'll see you in a little while. try that again. Give me a second and I will try and fix this for you. Is my audio a little bit quiet? Sorry. You've probably all been suffering. Turn your speakers up loud and it's going to hurt you now. Okay. All right. Okay, so this work is by Zhang X et al. And it is called Anomalous Nuclear Phenomena Associated with Ultra-Fast Processes. Jinglu Yang, Xiaoping Zhao, Chun Lui, Liaying Wang, and Zhongliang Zhang. Department of Physics, Beihang University, Beijing, and Institute of Chemistry, Chinese Academy of Sciences, Beijing, China. This is dated 2006 and it was presented to ASTI at the 7th International Workshop on Anomalies in Hydrogen Deuterium Loaded Metals for the ICMNS. And I started highlighting this and I realized I probably have to highlight all of this. Quantum physics predicts the existence of underlying sea of 0-point energy at every point in the universe. If the 0-point energy is real, there is the possibility that it can be tapped as a source of power or be harnessed to generate propulsive force for space travel. In our previous papers, anomalous excess heat and localized nuclear reactions on the surface of electrodes in electrolysis cells have been observed. A physical model of transient vortex dynamics with torsion coherence with the 0-point energy has been proposed by Jinglu Zhang based on the ultrafast processes of triple phases area of the tip effect on the electrode surface. Right. What is he talking about? Tip of an electrode and you have triple phases, right? What are the triple phases? If you're working in an electrolyte, you would imagine that would be liquid, gas, plasma. Liquid, gas, plasma. Triple phases. Okay? Considering the large equivalent capacitance of electrochemical double layer. And so what is an electrochemical double layer? We will tell you. An electrochemical double layer is analogous to a double layer in plasma physics. Analogous to a double layer in plasma physics. Triple phases, solid, liquid, gas, plasma, they're your phases we normally know about. If we're talking about just the electrolyte, it would be liquid, gas, plasma. It is presumed that the double layer can exhibit nonlinear electrical responses with spatial and temporal variations confined to microscopic areas by the tip effect. So double layer here is the space charge distribution. What it's basically saying here is the space charge distribution is highly nonlinear. Okay? So essentially, the same thing that's going on in a Ken Shoulders exotic vacuum object emitting device. Double layers and space charge. Experimental results of transient processes with ultrafast phenomena with nanosecond duration in electrical discharge systems, including electrolysis cells, have been presented. We're talking about something that is very similar to the simple experiment by Takaaki Matsumoto. When Pons and Fleischmann announced their revolutionary results, most of scientists in a variety of fields rushed to confirm them. No heavy energetic products like protons, tritons, or neutrons, and no gamma rays have been found. That's not strictly true. They were surprised with the negative results. Almost all of the scientists conclude that the idea of cold fusion was phony results. And that's not strictly true. However, during the period of April 1989, this is just after March the 23rd, like It's very close. It's April 1989, based on the tip effect of electrodes. Zhang Jinglui's group has evidently registered the really nuclear products with anomalous energy range by using CR39 solid detectors and the phenomena of nuclear transmutations. Within a month, they had registered CR39 tracks and nuclear transmutations. Since 1989, many laboratories in the world have observed nuclear reactions, excess heat, and heat after death in electrochemical systems. T. Amori et al. Found that there is no significant difference between the excess energies between H2O and D2O electrolysis systems for the plasma electrolysis. A.G. Lipson found that during the electrolysis of palladium film on dielectric substrates as well as palladium black, the alpha particles ranging from this and proton near this are emitted. The transmutation of strontium, cesium into molybdenum, praseodymium with 8 mass numbers and 4 atomic number increases was observed by Iramura, who is leading this year's ICCF in Japan. Nuclear products with high concentration and tracks with highly collimated lines. This process from the desmotron and in Lener generally produces collimated radiation. And here it is. Collimated lines of low energy nuclear reactions in the electrochemical systems were recorded by CR39 solid detectors and films in our laboratory in 1989. Collimated radiation, that means parallel rays. It is supposed to use the concept of torsion field, this bit, twisty, torsion field, coming out of something, to interpret the observed phenomena, typically the properties of axial acceleration, memory effect, and polarized nuclear reactions with torsion effect. The vortex is the assigned workhorse of the universe. The vortex is the assigned workhorse of the universe, which bridges the invisible dark energy and the visible matter. Well, I'd say that was a boom right there. The vortex is the assigned work of the universe. Seta rotas. Vortex dynamics. The vortex and spiral structures are the archetype that appears at all levels of nature and laboratories. For example, spin of fundamental particles, atom structure with nuclei and orbiting electrons, vortex lattice in conductors, superfluid, dense plasma focus, lightning, quasar, etc. Transient processes produce non-equilibrium systems. So this is chaos, produce non-equilibrium systems. Therefore, create torsion field with high vorticity. Femtosecond laser pulse excitation of atomic noble gas cluster produce forward ion kinetic energies with 3 orders of magnitude higher than expected. The tip effect of the cathodes in the electrolysis cell appears to enhance those factors to create one nonlinear system with far from the equilibrium condition. Recent reports of dark matter and annihilation at the galactic center describe that cold dark matter near the galactic center is accreted by the central black hole into a dense spike. Particle dark matter annihilation makes the spike to be a compact source of photons, electrons and positrons, protons, antiprotons, and neutrinos. It reminds us that there is a similarity among pitting corrosion, what he means by is cavitation here, with electrochemical noise. So he's literally linking electrochemical noise with pitting erosion. Laboratory plasma pinching, dense plasma focus, for example, fast laser-induced ion beams and quasar spiral model with high energy cosmic rays in spiral center in spite of large dimension difference. So he's basically saying in all systems in the universe, it's scale invariant. Comparing the experimental results of electrochemical cells with excess heat and nuclear transmutation to astrophysics phenomena, it is supposed that the investigation of vortex dynamics of torsion coherence with the 0-point energy is essential for tapping the 0-point energy. Based on observation in the experiments, the following features are considered in order to understand the experimental results with electrical discharge systems. The local enhancement of the electric field on the cathode surface with the double layer is related to the protrusions and cracks similar to the tip discharge in air or in vacuum. So just what we've been talking about with these things, the tip discharge, the space charge enhancement here, he's saying that that's the same with a crack or a protrusion in electrochemical. And he's essentially repeating Ken Shoulders. He's repeating many authors in this field. The current distribution depends strongly on the surface roughness and the work function of the electron emission. I've already talked about work function. A high transient current density, 10 to the 8 amps per centimeter squared. This is the work of George Messiat's from cracks and protrusions. For ectons are EVOs, are ball lightning, are magnetotor electrical radiation, could be expected due to enhanced field and instantaneous process. Torsion field and tapping the 0 point energy. Transient processes in an open dynamic systems always create the vortex effect. Always done. In metal deuterides, there exists a possible transient dynamic process which may generate close pairs and clusters of deuterons and motion to induce strong screening effects on the repulsive barrier. There is a variety of nonlinear processes which could be taken into consideration. Temperature rises locally. I agree. I believe we've seen that in these discharges today. High persistent field, in addition to transient electric and magnetic fields, lead to the polarization and coherence effects. Yes. Of the deuterons with quadrupole momentum. Influence of magnetic field on the distribution of deuterium. Yes, of course. Azimuth magnetic fields created by transient emitted electron current with high flux density due to the tip effects causes redistribution of deuteron density on the interface zone of palladium cathode. Experiments showed that the phenomena of current filaments and chaotic processes in lattice are extremely sensitive to the magnetic field. Our current understanding of science is like a puzzle with a large missing piece, 0 point energy. Various scientists around the world have been discovering anomalies of phenomena attributed to the conversion of 0 point energy. The combination of ion vortices or vortex rings. Ion vortices or vortex rings. Ion vortices or vortex rings. Vortices or vortex rings. With abruptly pulsed bucking magnetic fields could result in the direct manifestation of energy and gravitational anomalies. In order to theoretically allow the coherence of the 0 point energy, two fields of modern physics must combine. Theories of the 0 point energy interacting with matter and theories of system of self-organization. Boom! I think we're nearly there. I think we've been combining those things. The facts of production of nuclear reactions in room temperatures, solid state setting, including cold and bubble fusion, and ultra-fast laser plasma interaction could be explained by physical model of transient vortex dynamics with torsion coherence with the 0 point energy. Okay, he talks about the experimental results there. And these pulse trains he does. He talks about the molar concentrations here, the vessel that it was in. However, if the cathode was a piece of wire netting and the anode was a tungsten rod at the same voltage that here, now you can see where I found this when I was looking for researchers that had worked with tungsten. The width of the waveforms could reach 300 microseconds. Conclusion: the phenomena of so-called cold fusion with excess heat and anomalous nuclear reactions could be explained by transient processes in the triple phase area of the tip effect. Vortex dynamics of non-equilibrium system with non-linear processes leads to tapping the 0 point energy. Okay. And then, who's he got in here? Amori, some Japanese there. Mizuno, very good. Iwamura, very good. And many papers by him. Zhongli. Okay. All right, fine. Now, he updated this paper, and bearing in mind he's going over his theory, which he presented in 1989, he then goes on to refer to this work again, and you'll see some very similar themes in this next presentation here. So this is extraction of clean and cheap energy from vacuum. The main principal author we've just seen, Jingliu Yang, Xiaoping Zhao, and Weiming Peng, Department of Physics, Beijing. And at this point here, and this paper is from 2013, the third author here is working at the Quantum Engineering Lab at the University of Colorado in the US. Nature abhors a vacuum. Based on the theory of zero-point energy, broken symmetry, and the tip effect, useful energy and power has been extracted from quantum vacuum experimentally. The experimental results of the anomalous nuclear reaction reported by Zhang, Bockris, Miley, and Mizuno et al. Challenge the current atomic model. It appears that there are situations in which nuclei split open at the stimulus of only chemical energies. A high energy concentration in the double layer on the cathode surface is observed with the existence of anomalous nuclear transmutations in electrolytic cells. Well, certainly Matsumoto is going to agree with that. A model of vortex dynamics based on the zero-point energy, Casimir effect, and torsion field with tip effect and related nonlinear processes is proposed by Jingliu Yang to account for the anomalies of the experimental phenomena. The combination of the energy vortex or particle vortex rings, with abruptly pulsed bucking electromagnetic field or turbulence fluid, that is cavitation, could result in the direct manifestation of energy and matter transformation. The modification of the spectrum of the zero-point energy by dynamic Casimir effect is essential for nuclear transmutation of Fleischmann and Pons effect. There is reasons to strive for better understanding of the physical interpretation of so-called cold fusion. Quantum theory predicts that the vacuum of space in the universe is filled with low-energy electromagnetic waves, random in phase and amplitude, and propagating in all possible directions. When integrated over all frequency modes up to the Planck frequency, 10 to the 43 Hertz, this represents an enormous potential source of energy with a density of as much as 10 to the 113 joules per cubic meter, which is far in excess of any other known energy source. Andrei Sakharov, the Soviet physicist, argued that we should regard all matter as floating in a sea of energy. Modern physicists tell us that the space between the stars and the space between particles that which make up that matter are filled with a vast amount of fluctuating energy, fluctuations that are fundamental to our view of the fabric of nature. Researchers failed to explain the phenomena related to so-called cold fusion under the physical frame of mainstream for many years. A theoretical model of trapping the zero-point energy associated with dynamic Casimir effect and torsion field, including spin and rotation and movement, has been suggested by Jingliu Yang to be used for describing the phenomenon of cold fusion since 1999. The system of cold fusion is awkward to use since it needs several weeks of electrolysis to turn on, and the phenomena heat after death and even nuclear blah 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 blah. Extraction of energy from the quantum vacuum. A system is disclosed for converting energy from the electromagnetic quantum vacuum available at any point in the universe to usable energy in the form of heat, electricity, mechanical energy, and other forms of power. And this patent here is Bernard Heisch and Garrett Modell, okay, from 2005. By suppressing quantum vacuum zero-point energy at appropriate frequencies, a change may be effected in the electron energy levels, which will result in the emission or release of energy. Mode suppression of electromagnetic quantum vacuum radiation is known to take place in Casimir cavities, and they talk about a bunch of people that have done that. A Casimir cavity refers to any region in which electromagnetic modes are suppressed or restricted. When atoms enter into suitable micro-Casimir cavities, a decrease in the orbital energies of electrons in atoms will thus occur. Such energy will be captured in the devices. Upon emergence from such micro-Casimir cavities, the atoms will be re-energized by the ambient electromagnetic quantum vacuum. In this way, energy is extracted locally and replenished globally from and by the electromagnetic quantum vacuum. This process may be repeated an unlimited number of times. In case of electrochemical double layer EDL, similar to dynamic Casimir cavity, ultrafast processes associated with torsion field, extraction of energy and anomalous nuclear transmutation could occur at localized microscopic regions. Okay, this is the statement. I'm not fully in agreement with it. I will talk about my view on this at Tesla Tech in August. The energy is from the same source, but the way it is manifested directly and the way you can interact with it and the way you can recycle it is slightly different. And my theory is based on observed observations, repeatable observations, and has implications for direct application. Okay. Electrochemical double layer here. So, and effectively he's talking about Dardic here. And I'm getting quite excited when I'm reading this in this 2013 paper, because I'm kind of recognizing some of the names here. And I'm just going to go right to the end here. Oh dear, not shrinking it that much. I want to see who's in the references here. And here we go. Bernard Heisch. So Bernard Heisch is a colleague of Harold Puthoff. Bernard Heisch visited Dr. George Eagley, who came with me to India and came with me to Japan, World Exploit and Ball Landing in 1983. He is a colleague of Harold Puthoff in this particular paper here, Inertia as a Zero-Point Field Lorentz Force, Physical Review A from 1994. Here we've got Dardic and Arik Elbo here. These people worked on the Sidney Kimmel Institute of Nuclear Renaissance at Missouri University. Here we've got Harold Puthoff here, zero-point fluctuation force. Down here we've got George Miley and Patterson of the Patterson cell. We've got Tadahiko Mizuno here. I mentioned him earlier with his tungsten. We've got Mark Peringa here, low-energy nuclear reactions with Casimir effect. And then, oh my God, who have we got here? We've got Pavel Osmira. The Vortex Fractal Theory of Universe Structures, Proceedings of the Fourth International Conference on Soft Computing, ICSC 2006. So he published his paper. This is the guy, you might recall, we are working with him to produce these Vortex water treatment systems. Here he is when he does his, it would appear, his initial discussion on his vortex fractal ring theory of universe structures. So at this point he was looking at universe structures, and by 2009-10 he was actually talking about the fractal model of an electron. Very, very interesting. Okay, where are we? Were we there? No. Okay. All right. So, a method for transmutation of elements. Recently, Ron Kovac and Toby Groats of Colorado repeated Walter Russell's 1927 work. Everyone's going to like the fact that Walter Russell's mentioned here, which was verified at the time by Westinghouse Laboratories. Russell found a way to change the ratio of hydrogen to oxygen in water vapor inside a sealed quartz tube, or to change the vapor to completely different elements. Their conclusion agrees with Russell. The geometry of motion in space is important to the atomic transmutation. Listen to what it just said there. Their conclusion agrees with Walter Russell. that the geometry of motion in space is important to atomic transmutation. Kovac shorthands that the idea of geometry as space bending. A plasma tube with only plasma of nitrogen gas and magnetic shaping was used to create the missing link element 5 lithium. The plasma tube has only 2 needle points, blah, blah, blah. So he talks about it. It's well known that matter is a wave form energy pattern in the medium. Quanta turned out to be more like waves than corpuscles, that is, particles. According to Russell's description of the wave of creation, the wave is described as causing the integration of matter at poles and disintegration at the equators. Matter integrates by the contraction of one pair of spirals around the shafts which wind it into spheres by the way of its poles, and disintegrates it by expansion of the other pair which unwinds it by way of equators. Anyway, one's winding, one's unwinding. He goes into the explicit nature here. He says, the tightly wound toroid of matter, centripetally bound and compressed, mass can then either unwind back through its axis as it turns inside out as energy production, heat, electricity, and light, or it can unwind equatorial as a catenoid spiral, which is a weird word, in a secondary mass formation to form various elements. So it's saying you can either yang it into heat, electricity, and light, or you can yin it into other elements. He doesn't say yang and yin, I'm saying yang and yin. But that for me is a boom. Literally, this is what we observe. The matter is transformed either one way by unwinding it, or the other way to wind it. Thus, mass energy transmutations occurring as in Russell's descriptions of motion to a to and from wave field cube well boundaries. Wave field. This is bad translation from the Chinese. Boundaries to and from mass spherical century boundary. The creation of mass 5 element, the 5 lithium, is offered as support for the notion, blah, 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 blah. Special characteristics of 0 point are that it's virtually infinite energy density and that it is ubiquitous, even present in outer space, and these make it very desirable. And here we go, we're talking about J.J. Thomson reporting helium and neon transmutation. So, okay. It was said that the important subject of physics is to study the phenomena of resonances. Condensed matter nuclear science involves the resonances of energies at the level from MeV to gigaelectron volts. A concept of the so-called cooperative resonance synchronized processes proposed by F.A. Gariv et al. The low-energy nuclear reactions in the whole system, nuclei plus atoms plus condensed matter plus environment, can occur at smaller threshold energies than the corresponding ones in free constituents. Okay, all right. Vortex dynamics and torsion field. It was said that the basic energy unit is vortex, and it is fundamental to all entities, particles, atoms, cells, organs, mind, the planet, solar system. Thank you very much, Benefice TV. Thank you. It's very kind of you for that donation. Solar system, galaxy, universe, etc. The latter are just a few stable fractal levels. Fractal? Did I see fractal in there? The latter, that is galaxy, universe, are just a few of the stable fractal levels in the universe. The vortex and spiral structures are the archetype that appears at all levels of nature and laboratories. For example, spin, and he's repeating what he said before, of fundamental particles, atom structure with nuclei and orbiting electrons, vortex lattice in superconductors. That's a new point there, and I agree, I've mentioned it before. Superfluid, dense plasma focus, lightning quasar. As stressed by Nachalov in his paper titled Theoretic Basis of Experimental Phenomena, over the course of the latter decades, tens of unexplainable microscopic and macroscopic effects in natural sciences, and especially in physics and biology, have been revealed and investigated. It should be emphasized that the large part of these phenomena were demonstrated by objects having spin or angular momentum, including so-called spintronics. In recent decades, torsion field has drawn an increasing number of scientists' attention, thus plenty of experiments and literatures have turned out on it. A torsion field is the result of rotation, spin, and certain forms of changes of them, such as spin flip. Torsion arises from intrinsic spin and will be large when a body is highly polarized. Thus, so when you have polarized water and you spin it in a vortex, in an ultra experiment, you're going to get the magic. Thus, one area of research will identify astronomical objects which have high polarization and therefore strong torsion fields. Calculate the effects on infalling objects and energy radiation of the torsion field. That is to say, the rotation of something may cause some certain forms of curvature in space around the rotating object. Some properties of torsion fields are identical to the properties of gravitational fields. Torsion emissions neither weaken with distance nor absorbed by natural media, and they have a group velocity no less than 10 to the 9 C. The properties of torsion fields, such as persistence, tapping, the zero-point energy, faster than light, etc., remind us to give correct description of the anomalous nuclear reactions. The model of vortex universe opens up a new way to reveal the origin of inertia and mass, and to understand astrophysics. The heat source which powers our sun is not the hot fusion scenario that demands temperatures of many tens of millions of degrees to fire the nuclear furnace. Boom! I agree completely. Energy extraction by dynamic Casimir effect related to torsion coherence with the zero-point energy are undoubtedly more in tune with nature's way of doing things. So he goes on about the local enhancement of the electrical field on tip electrodes, and it's similar to the tip discharges in air, like we were looking earlier. He's saying it's similar to this. The current distribution, and he talks about the same current level as Messias does in its ectans. He then repeats this thing about what he did in 1989 on CR39, a manuscript. And this is where it gets a little bit sad, and I kind of feel a little bit of his pain in this commentary here. Similar to the kind of pain that Matsumoto clearly felt when he was being ignored with similar kind of research. A manuscript, Micro Pinch in Cold Nuclear Fusion, about the experimental results by Jinglu Yang, Ning Zhu, and Laiyun Han, was sent to the editor of Nature magazine in September 1989. Dr. Philip Ball, he's naming names here, assistant editor, wrote on this manuscript, registration number, he's literally saying it was registered at this number. The referee finds your results interesting. The referee clearly feels that your experiments represent an interesting approach to the studies of cold fusion. In September 1989. For the referee, he wrote, I found manuscript this one quite interesting and recommend that you publish it. This manuscript was not finally published in Nature for some reasons. However, its preprint copies were distributed at many related laboratories worldwide. The basic contents of this manuscript were collected in the AIP conference in 228 and entitled Point Effect and Non-Equilibrium Conditions in Electrolysis Experiments, while the principal author, Jinglu Yang, was invited to give an oral presentation at the Conference of Anomalous Nuclear Effects in Deuterium Solid Systems in Utah in 1990. So this is the cavitation spot that is created as a track in CR39, presumably in this work done in April 1989. So imagine this guy's torment. He's sitting there and he's like, he's got this idea that vortexes and ring solitons, essentially, he didn't say solitons, but ring vortices, are producing torsion, and that is cohering and collimating and winding and unwinding matter, accounting for the energy production and the transmutation. In 1989! And it wasn't published in Nature, despite that the reviewing person recommended it was published. Imagine where we would be today if nature had actually published that. Imagine where we would have been. Frustrating. I don't know if this guy's alive. I'm going to try and reach out to him. The tracks of highly directional particles, figure 1, might be a variety of products of nuclear reactions on the tip or protrusion of the electrode, such as protons and alpha particles, including clusters of high-density charge of electrons with different size according to experimental results by Shoulders. That is Ken Shoulders. Such pattern of tracks offers the evident factors of channeling effect of crystalline metal electrodes, particle acceleration by torsion field. Therefore, amorphous surface of the electrode would not benefit to a nuclear reaction. Anyway, localized transient processes create vortex effect due to non-equilibrium phenomena. The axial acceleration of particles by vortex dynamics occurs naturally. Stochastic theory of induction time and potential of pitting corrosion, that's cavitation, has been used for the study of corrosion phenomena for many years. However, physical meaning is unclear. Has anyone seen it yet? From figure 2 here, one could infer highly oriented beta decay-like electron traces observed by autoradiography, nuclear transmutation. Thank you very much, Black Tie. Very much appreciated for that £20. And isotope production only took place in a minute area. Heat after death. The persistent behavior of torsion fields similar to nuclear weak interaction or weak force. Well, the persistence behavior of torsion field. We know that the torsion field persists. We know it. We have it in the in what I just showed you with the ANRAX device. You have that torsion field, I believe, is pulling in the subsequent discharges. We know that in Bogdanovich's work in water flow plasma discharges, you have these tori moving around on the metal 2 days after the experiment. That is persistent torsion field in my book. But look at this diagram. Oh my, what are we looking at here? What are we looking at here? Schematic presentation of micro-pinch spiral by tip effect in the electrolysis cell. Okay, so what have we got? A, this hill here. This is our tip of the electrode. B, this is the spiral structure of the micro-pinch. Okay, going in like this, and look at it, look at it. It has one pole, one side here and another side here, and we've got 2 things coming out there and 2 things coming out here. This is a 2-order substructure, which necessarily, in my understanding, must have 2 subtors to that. So we have 1 tor with 2 tors, and those 2 tors are made of 2 tors. Spiral structure of micropinch. C is the electron beam. The electron beam is coming up, and the D is the crystal channel, and here is the ion beam. The ion beams are being fired back into the metal. Electron beam coming out, ion beam fired in. Well, doesn't this look a lot like electron beam coming out, ion beam firing back in? Electron beam coming out, ion beam firing back in. Wow. This is this. That is that. That is that. The plasmoid there, that is that. Those are both the same thing. One's a plasma, Eric Lener. That there, negative things coming out, electron beam coming out. This is the collimated beam, and this is the positive ions being shot back into the material. That is the same thing. That is the same thing. Wow. The behaviors of electrochemical double layer on an electrolysis cell should be intensively studied for revealing the existence of dynamic Casimir effect and ultrafast processes in the triple zone of electrode protrusion. So the triple zone, this area here where you have liquid, gas and plasma, of electrode protrusion, electrolysis, and gas bubble. It is proved that there is similarity of pitting corrosion, sonoluminescence, and nuclear transmutation in the triple zone due to transient processes. Nuclear reactions take place along crystalline channels due to the effects of focusing and collimating. The new elements for atomic number from 2 to 80 were found by George Miley, Jingyu Yang, and Tadahiko Mizuno. This could be interpreted by the periodic charge of elements proposed by Walter Russell. The mass number of the evolved elements recorded by Mizuno et al. Was distributed roughly in 4 groups. Okay. The behaviors of torsion field created by rotation of macroscopic matter or the density of spin angle momentum leads to transformation of matter and energy. It is worth further study. Matter has an innate tendency to self-organizing and generating complexity from chaos. I rest my case. Self-organization, order from chaos. This tendency has been at work since the birth of the universe, when a pinpoint of featureless matter budded from nothing at all. As Walter Russell's point of view, there is no such thing from one element changing to another. However, previous matter is only one condition for nuclear transmutation. The model of vortex universe based on zero-point energy and torsion field opens a new way to reveal the origin of inertial and mass and to understand astrophysics of the holographic universe. The heat source which powers our sun is not the hot fusion scenario that demands temperatures of many tens of millions of degrees to fire the nuclear furnaces. Energy extraction by dynamic Casimir effect related to torsion. So he's repeating that from his previous presentation. Strong nuclear force could be the results of ultra short range Casimir effects. Based on the experimental and theoretical results in laboratory of our team, an attempt to develop a new type of spacecraft of field propulsion is considered. The energy source of the spacecrafts could be one way for extraction of energy from physical vacuum through dynamic Casimir effect. The study of combustion under the effect of electromagnetic field could lead for extraction of zero-point energy and for decontamination of a stockpile of nuclear waste materials due to the effect of vortex dynamics. Natural element creation and modification of percentage of elements in our planet could be further studied. Conclusion. The vacuum is the matrix that contains all matter and all energy. Physicists have now confirmed, and he's referring to Pavel Osmira, have now confirmed that the apparently substantial stuff is actually no more than fluctuations in the quantum vacuum. Matter has an innate tendency to self-organize and generate complexity from chaos. The zero-point energy is responsible for stability of all matter. Low energy induced nuclear transmutations are predictable and could be anticipated to occur in a variety of low-energy non-equilibrium systems. The basic reason of all such phenomena, according to this author, appears to be coherence of random zero-point energy of the vacuum. The variation of frequency spectrum caused by dynamic Casimir effect should intensively be studied for a reasonable explanation of low-energy nuclear reactions. The combination of iron vortex or vortex rings iron vortex or vortex rings. The combination just missing a diagram, this guy. Just missing a diagram. Could result in the direct manifestation of energy and matter transformation. The zero-point energy emissions from Casimir cavities due to quantum zero-point fluctuations, which have been measured in a mechanical oscillator by O-Painter, are now more important than most people think. The development of low-energy nuclear reactions is imperative for the survival of the human race. A new theoretical model is associated with zero-point energy, and the torsion field for Lener should be worked out intensively. So we got the H, the blah, 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 blah. He refers to, in various other works, this guy, Peringa, who talks about low energy induced nuclear fusion via coherence of the quantum vacuum, zero-point energy in ultra-close range Casimir effects. And he has this thing which he calls zip fusion, which I think is quite a nice name. He also refers to George Osawa, one of our friendly guys, ball lightning, telearchin with the cavitation the last time before my paper with Binder and Huang, when cavitation was actually in a major paper. And he says, from peer-reviewed journals such as Physics Letters and Fusion Technology, this new process has been called Zypian fusion, which is just another silly acronym and stands for zero-point energy-induced plasma pinch of ionized entrained nuclei. As a matter of convenience, the truncated zip fusion is generally preferred. This label was chosen to earmark this new class of nuclear reaction, which is based in large part on the groundbreaking condensed charge research of Kenneth Radford Shoulders, related investigations by Harold Puthoff. Okay? And I will share these references. Okay? And this just focuses on the Casimir effect and Harold Puthoff's work and Ken Shoulders' work, and how this can lead to the understanding, and how transmutation is occurring, and where your different vacuum states are, and so forth. And he talks about some lovely experiment predictions here that we've actually observed. Things like 2 silicon-28 go to iron-56. Yep, I think we've observed that. We've observed carbon and oxygen go to silicon-28. Yep, I think we've observed that. Carbon and oxygen go to aluminium and hydrogen. Well, I've discussed that recently. And so on and so forth. Lots of classic ones like this one here. Silicon and carbon go to calcium, and so forth. Many of these ones we've observed. And then there's one other paper which is much older on Casimir force here, which is from P.W. Maloney. And I had a whole other book to go through, but we will do on another day. But essentially what I'm saying is, whilst I don't believe they got the whole structure, they definitely got the basics. They definitely, what I'd worked out in 2017 from studying those tracks on the fuel container of Suhas Ralkar produced ultrasonically, and the reactor crust and externals of the reactor of the late Neil Crichton Gold in his Lion experiments, that led me to the basic torus and ring vortex and the vortex. That's there. And that's what he's saying, in his view, is more than enough to cohere the 0 point. I've argued in my paper, which I encourage you to read, that a more detailed response as to why that is. I will go over this book that was shared with me by Alexander Shishkin. Alexander Shishkin is top level Soviet era scientist. All of the Russians respect him, and he's writing to me and saying, well, he sent this to me. It was a little while ago, but the book is so important. Bob, I'm sending you lectures and books. They help me understand that most likely the etheric solitons were formed from the attached waves of the second order ether. I will get a full description of what he means by that, but I think you can probably guess. So second order ether is this first order, and then second order is this. Yeah, probably. And so when you start to get down to the second order, you are seeing what produces that spiral mark. So that spiral of a galaxy that you see here in this paper at the top of the tip here, there. You know, and you see this in the work of, well, pretty much anyone, if you actually bother looking at it. Okay. Right, so I'm going to answer some questions here. But I want to thank, and I want to not thank Nature. Of course, Nature Scientific Reports published my work with Binder and Huang et al. So that's great. But had they published this work over here, if they'd published this work over here back in 1989, we might be in a very different place. Okay. If you've got any questions, I'll see if I can dig out any that you might have said there. There's some great humour going on there, so always wonderful to see, guys. I like Thoth's joke. A proton and a neutron walk into a bar. Proton says, "I'll have a drink." And neutron asks, "How much?" And bartender says, "For you, no charge." Thank you very much, Daz Pizzazz, for that £5 donation. Very much appreciated. So he asks, thunderstorm generator has gone dark. There were some tests done in Texas, I think, and then the book is being produced by Robert Haralick on his understanding of how things come together, and I think Malcolm and Jordan are in India and they're building units there. So that's what I can tell you. I have a bunch of images that are sent to me, and I asked Malcolm, what are they? Who's involved? Whatever. And I don't get any feedback beyond that. So, like, you know, that's what I know. Thank you, Muggle. How long do you think this will be mainstream? I don't know, but I think it's going to move pretty quickly. Because I think once we can literally invite anyone to bring their own materials in and see that their materials, that they bring the chain of custody, they see that it hasn't got any elements in, they see the actual thing occur with their own eyes, and then they see the bit where it struck and the bit where it came from put under the SEM, and they see the transmutations. It's just going to be like, try and explain that one away. Try and explain that one away. And then when you have this kind of work in the literature, where you have these brilliant people, I mean, these are not nobody. These are top professors at Chinese institutions. These are top professors like Matsumoto at Japanese institutions. These are the leaders in plasma and vacuum electronics in the form of Ken Shoulders. These are not nobodies. And when you see the book that I was going to share tonight, but it's going to be probably another 2 hours, to maybe 3, because it's just so mind-blowing what the work is in that particular book. And by the way, it's from 2003. You're going to see that, like, this might have to be the biggest open secret, and just no one's discussing it. But I think what we've done by really working hard to look at the samples, I think we've solved a lot of the problems that have been a historical problem to understanding why this particular shape is the shape it is in a vortex galaxy, right? But why? Well, I think we've got a good idea. Mr. Mission Control, I certainly would suggest that we're in Revelations. I have suggested that since 2017. Contraption says, somehow I think that once this is figured out and public, it'll turn out to be simple enough to be within the grasp for most people. Yeah, it's going to be. I'm pretty certain of that, actually. And the sun, it's wonderful to hear other people saying the sun does not work on hot fusion. It doesn't. It doesn't. It just doesn't. I've argued it before. Basically, the turbulence leads to coherence and self-organized structures. They form EVOs. the EVOs do their business with their EVO-ness, and they form these neutral structures which have a magnetic component, and they travel up the magnetic field lines on the solar prominences, and they destabilize because they haven't got access to the right flux of electrons and so forth, and they dishevel and they release, let's say, almost bare iron nuclei. And the bare iron nuclei then suck in electrons from wherever they can get them, and the electrons cascade down through the unfilled electron shells, and that produces the millions of degrees of temperature in the corona. So that fully explains why you get elements synthesized, why you get these so-called high energy photons coming from the corona, and the sun. It's very, very big. It's 99.87% or something of our mass of our solar system. It's most of it. We're a little speck of dust floating around it. And we're a small one of the specks of dust floating around it. The fact that they think there's hot in this middle and it takes a million years to get up, no, it's not happening. It's not happening. No, it's on the surface. It's on the surface. The magic's occurring on the surface. And it's a beautiful thing. It's cold fusion. What would sunspots be? They are collective instabilities in the overall system. Yeah, a lot of people have pointed me to Dr. R. I think you mean, yeah, the guy on Sky Scholar. Yeah, I don't know whether he's ever said anything like I've just said there in terms of, we know Lener produces iron. It's the most common element that's been seen in the study in 2009. I think actually by Miley it might have been. They see iron. Of course, it's got the highest binding energy per nucleon. Iron 56, nickel 62 a bit as well, but it's kind of like where you would go to, and of course it's magnetic, it's ferromagnetic, it's iron. You get iron-rich crenellated spheres at the center of these structures. Doesn't matter whether you use cavitation or you use plasma or whatever, you get the iron-rich crenellated spheres. And so if you're creating a lot of iron, and it's created from a load of protons and electrons and antineutrinos making neutrons and getting it all the way up to the iron, there's no extra electrons, is there, to fill in the shells, and there's no need for it when it's in that core because it's just a coherent blob. But when the matter is reborn and comes out, it's going to need a lot of electrons to fill out those shells. Interesting. DIY projects with Chowsis says, I see iron on copper coins after brush fires. Very interesting. Thanks for sharing that. Thank you again, Muggle1, for your donation. You see what the White House announced. Don't know. Don't know what you're talking about. They've announced a lot. That's what I know. Okay, you'll have to be more clear about what you're speaking about. I don't know everyone's names. Okay, I really wanted to find the time to get on to this next book, but it is 1 o'clock here. So I think I'm gonna, if you have any questions, I will share these papers in the blog in the coming days. But I have to say, the publishing journals really let us all down by not publishing this work in 1989. Shocking. Yeah, really, really shocking. But here's the money shot. That basically shows essentially what you're seeing in here, in the LPP fusion. That's the same thing as that. Electron beam coming out here, ion beam coming that way. I believe that these beams here are actually not electron beams, or they could be electron beams in part. They certainly are when you are looking at these kind of discharges here. You're having electrons coming out, but I think you're getting ions coming the other way. But I think what you do get is coherent matter coming out of here in a neutral state. And it is still a twisted vortex, and it can interact with ordinary matter in unusual ways, changing its properties. And I think it's part of what strange radiation tracks are. So there we have it. Thank you very much, Contraption. That is really generous, that $20. That really makes a difference. Thank you. Yeah, definitely the ether. Seeing that spot on the back wall and going through those thermal imaging, as bad as they were with only 6 frames a second, and seeing those tendrils going towards it, it was a really special thing. Let's see if further experimentation bears that out. But I think we've got quite far. Thank you very much, Phil, for that $20. We are going to make a driftwood UFO. It's going to be steampunked and wood. Steampunked and wood. Okay? Okay, so I will say buenas noches, dobranoc, a good night. Please share this widely when you have the links to the papers. And any questions, I would be very happy to answer them, as always. It's been a wonderful journey, this, and I'm so excited to share the presentations that I have to give to the world and the community at ICCF 25 in the form of a poster. I'm very excited to share the presentation at Cosmic Summit this year, Annihilating Time and Space. I've been wanting to talk about teleportation for some time. I don't think anyone will expect what I'm going to say. And I'm very excited. Thank you, Pamela, for the €10. That's very, very kind of you. I don't think anyone is going to expect what I'm going to say at Tesla Tech. But when you hear it, you'll go, why didn't I think of that? So, and as ever, I could be wrong, but I'm certainly very lucky. So, thank you very much, one and all. Have a great week.